So we're on this dealio here that starts out with a little bow tie, right? So we're going two-column proof here. We got two-column proof on top of that, and then a flowchart proof. Oh, we got all kinds of proofs today. Okay, this is fun. This is going to be a fun day. All right, number one, a two-column proof is shown. Fill in the blanks for steps 5 and 6 to complete the proof. So it's not a very difficult proof. You've got a couple of triangles here, and you are going to try and show that they are congruent. And the key piece of information that they give you that makes you know that that's the case is that B is the midpoint of both of those segments, okay? So first thing they do, like we talked about, you always start out with what you're given. B is the midpoint of AE, that's given. Since that's the midpoint of AE, what do I know about these two segments here? They're congruent. And we know that's true because that's the definition of the midpoint, cuts it into two equal pieces. And it also says B is the midpoint of CD. That is also given, and therefore we know what else is true. This one is congruent to that one, again by the definition of the midpoint. And now we have to weigh in and come up with something on our own. So number 5, what is the statement that we would make that would be proved, or the reason we would give would be the verb. Okay, now you got to be careful with saying angle B is congruent to angle B, because how many angle B's are there? 4. And if you really got technical, you could say maybe this is another one, and that's another one, and so there could be a lot more than that. So what do you want to say? Right, so let's go angle ABD, so we know exactly which one we're looking at. It's congruent to angle CBE. Okay? And that is by the vertical angles theorem. And so that tells us that this is congruent to that. Okay, yep, and then therefore the last thing you write is always the thing that you're trying to prove. And we know that those two triangles are congruent by side, angle, side. All right? Any questions on that?
No.
No. Okay, number 2 is the flowchart proof. I'm going to do it this little segment diagram over here on the side. Well, that's what I'm here for, is to explain that to you. So these are points on this segment are labeled A, B, F, C, and D. What they're saying is AB is equal to CD. What they're saying is the distance between A and B is the same as the distance from C to D. Right? And then it also says the distance from D to F is the same as the distance from F to C. Okay? So this is a flowchart proof. So they're saying AB equals CD, BF equals FC. That is given. And then over there to the right, it says something is true because of the segment addition postulate. Anybody got any ideas there? What you could write with that? And it's all based off of the fact that AB equals CD and BF equals FC. What can you do with those two things? Right. We're going to take those two and add them together. So what they're looking for number 1 is for you to add this side together and say AB plus BF equals CD plus FC. Okay? So that is the segment addition postulate, and that is that if you have a couple segments and they're equal to each other, or a couple pairs of segments that are equal to each other, if you add them together, then the result is equal as well. Okay? All right, what else do we got going here? We get something from the addition property of equality. What can you do with that? I think we might have done something a little backwards here, but we'll power through it. Anybody else see anything else? That's what we're trying to prove. Okay, and so what we know right now is that AB plus BF equals CD plus FC. So what they want us to write here, I believe, is AB plus BF equals what? What? AF, This little piece plus this little piece equals the entire thing, okay? And what does CD plus FC equal? FD. This piece right here from F to C plus C to D would be the same as going the whole way, so that equals FD, okay? Therefore, we know that since these two things are equal to each other, the next thing they write is that that means that AF equals FD, and that's what we were trying to prove. So, oh, it's a multiple choice thing, huh?
Yeah.
I didn't even notice that. So what do we go with? D. Okay, D, because we've got AB plus BF equals AF, FC plus CD equals FD, and AB plus, yeah, those work out, so that is the answer choice D. Okay, waiting. So now we're just going to prove that. So first statement they make is that VWXY is a rhombus, and that is given. And what's the definition of a rhombus? What do you know is true if you have a rhombus? All the sides are the same. A rhombus is a parallelogram with 4 congruent sides. So that's the next thing they write is that WX is congruent to XY, which is congruent to YB, which is congruent to VW. All right? Number 3, we don't know what. That's what we got to fill in. But we know this because if a figure is a rhombus, then it is a parallelogram. So what would you say would be true because of that? Okay, so we're going to say the sides are parallel basically. WX is parallel to VY. Did you do both at the same time? And also WV is parallel to XY. Okay, so the sides are parallel because if a figure is a rhombus, then it has to be a parallelogram. And you know that parallelogram has parallel sides. Okay, number 4 then points out that WZ has to be congruent to ZY. And you know that that's one of the things that we learned before is that the diagonals of a parallelogram bisect each other. So I'll mark that on the diagram. Number 5, ZX is congruent to itself, and that is once again the reflexive property. So we got a little one going right there. Therefore, we know that 2 triangles on our shape, or our diagram, are congruent. This triangle WZX is congruent to WY ZX. How do you know that? What do I have labeled on those triangles? How many sides, how many angles? Side, side, side. I've got 3 sides here, and I've got 3 sides here. So I know those 2 shapes are congruent to each other because all 3 of their sides are the same. Okay? Therefore, number 7 says angle WZX is congruent to, so WZX, so this little guy right here is congruent to angle XZY, and that's that CPCTC thing. Do you remember that? Corresponding parts of congruent triangles are congruent. Once you know 2 triangles are congruent, you know everything about it is the same. We also know that those 2 angles are supplementary because they are a linear pair. And therefore we know that they're both right angles, right? Because the 2 angles add up to 180 degrees and they're both the same. What has to be true about each of the angles? They have to be right angles. 90 plus 90 is 180. And I'm pretty much thinking that we would be done there. But they keep going. They say that means that the 2 measures are the same because that's the definition of right angles. And then number 11, what's the last thing you always write in a proof? What you're trying to prove, which is in this case that VX is perpendicular to WY. Okay? They don't like you. All right, so then number 4 is a paragraph proof.
Why?
Why what?
Why do you have to be a paragraph proof?
It's just a fill in the blank thing. You're going to be okay with it.
I
Put it
see, I thought you
below.
had to write it.
It's a multiple choicer, yeah.
Okay.
Okay, so number 4, we have a right angle right here, EAC. And then we've got some other random angle over here, 3. And we know that angle BAC is a right angle. And we know that angle 1 is congruent to angle 3. Okay? And so what we're trying to do here is we're trying to show that if these two angles are the same, and these two angles add up to 90 degrees, what's going to be true about these two angles? They would also add up to 90 degrees, okay? And so paragraph proof is not one that we did, but it's just sort of explaining in words, as you would if you were talking to your parents about what you did in class today. You would say, well, Mom, since angle BAC is a right angle, that means we know it has to measure 90 degrees, right? That's the definition of a right angle. By the what? Angle addition postulate, we know that these two angles have to add up to the whole big angle. Okay? So number 1, we decided to fill in with angle addition postulate. Okay? So we know we're either on to B or C. By substitution, so we started out, we've got the measure of angle BAC equals the measure of angle 1 plus the measure of angle 2. But what do we know is true about the measure of angle 1 plus the measure of angle 2? That means that, yeah, they're 90, so I'm going to replace this with 90 degrees. I'm going to substitute that in there. Okay? And also, since angle 1 is congruent to angle 3, the measure of angle 1 equals the measure of angle 3 by the what? Definition of congruent angles, which is if two angles are congruent, then they have the same measure. And so we are done with what? Nicely done. Okay, good. And now we get into some new fun stuff. Remember that I told you there was a little bit of logic stuff that we still had to learn. Okay? If you're a note taker, this would be a random little piece of notes. Okay? So here's a little short lesson in logic. We are going to start with what's called a conditional statement. And these are statements that you've messed around with all year in this class. If a polygon is a triangle, then it has 3 sides. So the condition is if it's a triangle, and then the statement is it has 3 sides, okay? And so we're going to write our own conditional statement, which is if the Bulldogs win on Saturday, then what will be the case? Then they will be district champs.
Well, we're already district champs.
I'm talking fast pitch.
Oh, okay.
Okay? So that is a conditional statement. If the Bulldogs win on Saturday, then they will be district champs. The converse is what you get when you take and you switch the two things around. Okay? So I'm going to take the if part and put it at the end. And I'm going to take the then part and put it at the beginning. Okay? So that would be if the Bulldogs are, I'm going to abbreviate here, district champs, then they won on Saturday. Okay? Okay, so for converse, all you have to do is switch it around. Okay? You just take the first part and make it the last part, take the last part and you make it the first part. The inverse, do you remember this? I did this before.
Probably not.
Do you remember?
Is it the total opposite?
It is the total opposite, not the total opposite, it is the opposite. And so that's where you make them both the opposite of what it was. So if, right, the dogs don't win, then they are not district champs. Okay, is the inverse, is you keep it the same way and you make them both negative, is what they say in math terms. You negate each one of them.
In mathy on us?
And I'm getting mathy on you. Can I turn the page?
Yeah.
Because there's one more. Can I turn it now? All right, then the last one is the contrapositive. And the contrapositive is when you do both. You flip them around and you make them negative. Okay? So since we said if they win on Saturday, then they're district champs, you would flip that around and say if they aren't district champs, then they didn't win. Okay? So you change the order of the two things and you make them both the opposite.
So it's the converse and inverse?
What's that?
So it's like
Yeah, it's like the converse and the inverse put together. Okay? So that's how that all works. And there's a relationship between whether the first statement is true and what you know for sure would be true about some of the other things that we'll do a little bit here maybe right now. Okay, so on number 3, back to your packet, the statement that they start with, the conditional statement that they start with is, if two angles are acute, then they are complementary. Okay? Is that true or false? False. So you circle your false there. The converse of that, you have to flip it around. So how would you take that statement and flip it around? If two angles are complementary, then they are acute.
that's true.
Okay, so if two angles are acute, then they are complementary. And we went with false on that, right? And then for the converse, you would flip that around and say, if two angles are complementary, then they are acute. Is that true or false? True. Okay. Shh. Hey, quit talking. Quit having fun.
That's what's that part of the
Okay, next one is the inverse. And so what do I do with that again?
Negative.
Jacob?
You make them opposite.
Okay, so you would say if two angles are
Not acute.
not acute,
They
good,
are not complementary.
they are not complementary.
That's
Put a
true.
comma on there. No. Like you,
Okay, so if two angles are not acute, then they are not complementary. Is that true or false? True? And then the last one, the contrapositive, we can take the statement we just wrote, which we made negative already, and flip it around. So that would be if two angles are, we'll go with this one first, not complementary, then True or false? False.
So it's false, true, false.
False, true, true, false. And it turns out that that's always going to be the case. Okay? The conditional statement and the contrapositive will always have what's called the same truth value. In other words, if this is true, then this will also be true. And if this is false, then this will also be false. And then the converse and the inverse also have the same truth value. If this one's true, then that's true. That's false, they're both false. Okay? In the last one, the example we did about fast bench, it wasn't a very good example because what was true about all of those statements? They were all true. Okay, so that didn't really help us very much, but there you go. All right? So that's how that goes. Yeah. Go. So you have to
Is
remember.
the final,
Seriously?
is
Seriously.
that a big part of our grade?
It's a state test.
Oh,
It's
yeah,
not
okay.
any part of your grade. It just determines
We
whether
have a
you,
final of the year?
it just determines whether you graduate from high school or not. It's not a big deal. Okay?
Seriously?
Seriously.
Cereal?
It's not.
Oh my god, they can hear me. Yeah, you're in.
Yeah.
Dang.
We still have to take this.
Yeah, we have to take it. We don't have to worry about it.
Yeah, because you're old, so you're through.
Do you
What?
know there's a kid named Tag? You're it. Yeah, like, Tag, you're it. And he's a kid. He goes here. Yeah, there's Tag.
Okay, sweet deal. Can we?
Why is he
hey,
thinking that?
hey. Math. All right, so now we're going to do some logic stuff, just basically general thinking your way logically through some things. So the first one says, show that the conjecture is false by finding a counterexample. So their claim is that if you have two numbers A and B, and A is bigger than B,
It's not.
then that means that if you divide A by B, your answer will always be positive. See, this one's bigger than that one, right? So if you divide a bigger number by a small number, it's always going to be positive. Okay? Well, give me a counterexample. So your first choice is A is 11 and B is -3. Well, that was easy, yeah. Is A bigger than B in this case? Yeah, so we've met the conditions. Is A divided by B positive? No, because 11 divided by -3 is a negative number, so that would be less than 0. So that is a counterexample to their argument. Okay? So that proves that the conjecture must be false. Okay? All right, and then number 2, same thing. We have to explain what this person did wrong. So we've got these 3 triangles here, or 2 triangles here. And we've got some sides that are congruent. And since we have 2 sides at an angle that are congruent, they conclude, therefore, that triangle ABC is congruent to triangle PQR by side, angle, side. Because we have 2 sides at an angle. What's wrong? Why is that not true? Why isn't that true?
It's the wrong side.
Yeah.
So which one is it?
A.
A. The student mixed up the sides and should have said AC is congruent to PR. Is AC congruent to PR? Nope, it's not A. A. B. The student mixed up the angles and should have said angle ABC is congruent to PQR. Is C. The student needed to know that AB was congruent to PR in order to conclude that the 2 triangles are congruent, right? This angle right here is in between these 2 sides. So you've got a side angle side here, but this angle right here is not in between these 2 sides. So for this one you have a side-side angle. And since these 2 match up, then you can't say that the 2 triangles are necessarily congruent. So that is answer choice C. All right? Okay, will you pass it forward, please?